Hello everyone, and welcome back to the Odyssey project. I think in this episode we're going to do a couple of things that do not involve the Siemens software as much. The first thing I'm going to do is show you a little bit of how the AutoCycle actually manifests itself on a trainer. I have some old video that I'm going to chop up for that, kind of show you a little bit about how machines start up. And also I'm going to export some tags and use them in Excel and show you a way to easily create new tags and re-import them back into the project. This is a little bit of a time saver, and hope you enjoy it. Usually the first thing you'll do when starting a machine or system is to ensure the e-stops are pulled out, guards are clear, doors closed, and you will engage power. This ensures that the master control relay, or MCR, is engaged. The MCR connects power to some of the output cards, which allows the PLC to control the physical outputs and actuators. Notice that the stack light has power even before the MCR is engaged. Some devices are on switched cards, these are on unswitched cards. The next thing we did in the previous video was put the machine in auto mode, press the cycle start push button. The horn sounds while the machine is starting, and then you're in AutoCycle. This is where we left off in the previous video, and I'm going to have to download my program again, so this is a good opportunity to show everybody how to get the program into the simulator. So first, we start the simulator up using the icon, of course, and it comes up the same way as you had it open last time, so it remembers all of the settings. However, notice that there aren't any symbols here because the project hasn't been downloaded yet. So hopefully the symbols will attach themselves. We'll take a look at that. First thing to do is go ahead and download hardware. Go here into the hardware setup. Hardware gets opened up. Of course, it's already been saved and compiled, but it doesn't hurt to do it again, just to make sure. If you hit download, it knows what kind of hardware it is. Notice that the address here matches the hardware setup that we did in here, the channel setup, and that the module is a CPU 841, which is the simulator. So I say OK, and you can kind of see the bar graph there briefly. The next thing to do is to download the blocks, and to do that you can close the hardware configuration. So here are the blocks. In general, you want to download blocks in reverse order. I like leaving this view, which is the details view. It shows the size of things and what things are, the names, symbolic names, what language it was created in, that sort of thing. So we have two blocks here. Of course, you don't download the VAT. The VAT remains only on the PC. You hit download, and the processor should be in good shape. And of course, you always go to run P rather than run. And it flashes, and the system fault goes away, and you're there running, and notice that it reattached all of the symbols. Speaking of symbols, we are going to do a little bit of work with the symbol table. You'll find the symbol table here in the program. I open it up, and there's the symbols that we made in the last video. Now, to export the symbols, there's various different formats that you can export it in. You can export it in ASCII, but we want to do it in data interchange format, and we'll call it Odyssey symbols. Of course, you want to put it somewhere where you can find it later. We'll save it. And then we will open it. So the best way to open it that I've found is to just open up a new Microsoft Excel spreadsheet. And there is a spreadsheet. And then go to Open. And browse to the format, and there it is. Now you notice that the other worksheet that we opened is still open. But now if I want to add something, everything is in the correct format. Now often when you export, you will end up with the number 126 if I were to look at this in Notepad. And in this table, that 126 is gone. This is pretty much in the format that we want it to be in. We've got some descriptions here. You want to keep things in the exact same format. So an easy way to do that, if for instance I want to make a bunch more push buttons here, is to copy an existing push button. I'll put it down here. And then change the symbol name to, we'll call it HMI PB1. And we'll put this up in the 200 range. This does save you a little bit of typing. So some of the advantages that you have in Excel is you can see here that as I drag this down, I get incremented numbers. You can't do that in the symbol table. Now if I increment here, looks like they also go to the right number. Make sure you don't drag it down to 200.8 because there is no 200.8. Of course, it starts at 201.0. But you want to just copy everything down as is. And so here we've created 7 push buttons, HMI push buttons, complete with comments, things like that. We will save it. And I'll say yes, and I should just be able to import this. So we'll try and import here. Says you can't undo it. No errors, no warnings. Do I want to open it? There we go. And you can see that I've added my push buttons down here. So this was a quicker way, especially if I had hundreds of things that I wanted to add, to create lots and lots of symbols at one time. So you do want to do a save here. You're saving it back in the ASCII format. And we are ready to continue. We've modified our symbol table. Now another thing that I like to do whenever working on a project, either starting a project or working on somebody else's program, is to create a spreadsheet and start collecting information about the project and doing some organization. So you can see here we've got OB1, which is our main routine. We've got FC1, which is our system routine. And in my book, Advanced PLC Hardware and Programming, I go over some of the organizational structures for things like machinery and process control, that sort of thing. So we're going to be doing more machine programming here to start with. So we're going to use some functions in the lower end of the range, FC1 to maybe FC10, and doing some of our typical organization. Again, with Excel, you can do things like this where you increment numbers. So typically after the systems routine, as in my book, I would have an inputs routine, an auto sequence routine, maybe several auto sequence routines. So maybe we'll create a couple of them. We'll just call it sequence 1, sequence 2. Remember, we can change these names later. And then your output routine. So this is important that you actually call these in this order because of scanning, right? If I called my inputs routine after my outputs routine, then I would be servicing it and wrapping around and doing things in the wrong order. I would actually lose time. So inputs, sequences, outputs, alarms and faults, things like that. And I'll call these faults, and I will be calling the process control alarms. So we're going to go ahead and make some of these routines, and we're just keeping track of this here. The nice thing about spreadsheets like this is you can add sheets and put things like your Profibus addresses, Ethernet addresses, things like that. Just keep track of all the things pertinent to the project right here in a spreadsheet. And so it's always there if you need it. So we'll do a quick save as. And we'll just call it Odyssey Info. So I'm collecting a variety of spreadsheets in here. My videos are in here. My symbol table's in here. So that's why we organize things this way. So once it's saved, I will minimize it, and then we'll actually go create some of those blocks. So another function, FC2 is going to be inputs. This is where we do our input conditioning, things like that. And then we decided that this one was going to be sequence 1, and we can always rename this again. Sequence 2. Outputs. And faults. So now all of these exist. You would have a real problem, right, if you went into OB1 and called these and downloaded OB1 right now. But because these have names, right, I can call them. They're all right in here in the FC blocks. So creating a bunch of things ahead of time is pretty convenient. Now if I were to download this right now, of course, these functions are not in the processor yet. So I'd be calling something that's not there and I would fault. That is not a good thing. Remember, FCs are just like subroutines. That's really all they are. Okay, so now I've got all my subroutine calls in the proper order. And it's okay to download OB1, but you better download these other blocks first. Notice that when I save, the FC number appears above it. We can put comments up here if we want to, but I'll do that at a different time. So we've got our always on and always off. Then we've got all our subroutine calls. Then you go to the manager. Something that's generally important to do, always download in reverse order. So I hold down my shift key and I arrow up and I selected everything in reverse order. So it will download in that order, FC6, FC5, FC4, all the way down to FC1, and then it will download OB1. So if I didn't do that, what I would end up with is a fault, a system fault up here, because OB1 would go in there first, try to call these, and they wouldn't exist yet. So always download in reverse order. If you select from the bottom to the top, then you automatically get reverse order. And we say all, yes. And notice we did not fault. And an easy way to tell if they got in there is, of course, to show the online view. And there they all are. All right, so everything's in there, everything's running, and everything's happy. So remember this view, this is always showing what's actually in the processor, which includes all of these other SFCs and SFBs. Done a little bit of organization here. Now I'm going to go to FC1. You can go ahead and close this when you're not using it. I'm going to go to FC1, open it up. And here's our system stuff. But then we had the pulse timer, which very probably could be in the system routine. So I'm going to go ahead and hold down my shift key, select both of those. I'm going to cut this, and I'm going to put it back in the systems routine. You can put it wherever you want to. I think I'll put it at the end. Right, so here is our pulse timer. We'll even give it a title so that we can find it. Okay. Notice I have a lot of windows open here. That's typical of Siemens. Here are some outputs, so a good place to put that would be in the outputs routine. So once again, nothing here. We can cut this, the horn, and the stack lights, and that's the start. I cut it. That is the start of our outputs routine. We'll save this. Then we can close it. We'll save this. And we can close it. And we'll save this, but leave it open. Download everything in reverse order once again. Downloading all, everything, yes. And quickly go back and monitor. Looks like everything got in there. So we're looking at our flasher flash. Go ahead and open the systems routine. Monitor it. Do a quick test. Make sure everything's operating properly. So let's push our auto push button. We did go into auto mode. Now if I hold down my cycle start once again, cycle start push button, we're blinking the light. Oh, I bet we don't have a permissive, right? So I'm pressing, but I'm not getting my start yet. We'll do a cycle start permissive. Now the horn pulsed, you saw there, and we are in AutoCycle. So I can now let go of the cycle start push button. Everything's auto-cycling. If I have a cycle stop permissive and I hit the cycle stop push button, I immediately stop, and there's my blinking stack light, just like you saw in the initial video. That should do it for this video, number 7 in the series, and thank you very much.